All right, Mr. Stewart here, and this is going to be the day 15, chapter 6. This is about creating and documenting assemblies, and this is a part of the PowerPoint lecture that goes with this. So you can find that lecture down here where it says Autodesk Inventor 2021 Essentials plus chapter 6. I'm going to click on that, and it's going to open up in this little browser, and the first slide here is objectives of what we're going to be talking about through this chapter. Now there are options in assemblies that you can default to, things that you find favorable that you want to keep consistently to have your assemblies do, and these are the options right here. Okay, so we're going to look at how to actually create an assembly, a new assembly file. They have the extension of .iam, and we can start them multiple different ways. So I'm going to go right to Inventor here. You're going to see them in this quick menu area. You can just click on assembly here. You can go up to the word new right here and select this, and what you're going to see is multiple different ways to start assemblies. The standard.iam is right here. That's the one that I would tell you to use for non-metric parts. We do have a welding assembly here, and your templates list here is going to also have metric ones, and you can see there's lots of different metric assemblies, but just use the English folder here and pick on the standard IAM. So I'm going to click on that, and I'm going to say create. So this is going to go out and come back, and while that's doing that, we'll go, whoops, guess we'll go back to here. Yeah, there we go. So creating an assembly, you're going to need to first do what's called create place of components, and components are created in individual part files. And you place a component, and you can use the shortcut P if you want. Let's go back to this. So to place a component, you go to the word file, and you'll see the word place symbol down here underneath it. You can click on this, and you'll see different types of components that you can place, but we're just going to work with a regular component right now. And let's see, was there a specific component they want us to put in? Not right now, but anyways, so that's really placing components, is by selecting the items from that list. Now you can place components from other CAD systems like SolidWorks or other kinds of different softwares. CATIA comes to mind. So those are available to put in also if you want. We can also create components from assemblies. I don't do that very much. I usually create components in separate files, IPT files, and then bring them in. Sometimes it's good to build a new part on the assembly, and that is what this is talking about right here. And again, this is about creating parts in place. So the assembly browser is going to look like this. So this is the browser on your left-hand side. You're going to see little plus signs next to the different items that you have inserted. So crank 1 here, and then we have link adjust assembly number 1, and you'll see relationships, and you'll see 3 folders typically, and then you're going to see the constraints that were used to put this assembly together. Again, down here you're going to see link rod assembly. So these are completed assemblies that get put into the master assembly, I think is probably the best way to put it. Then we have occurrences of the assembly. So we have bracket here, and there's the first one that got put in, and then there's bracket 2, that's the second one that got put in. And we also have capacity, so that's the amount of space that your computer has on it that you are able to actually have open. And then if you go to put something together and find out that it has a problem, like it's not going to fit, and you want to make a change to an item, you can just double click on that item. That grays out the other components in the assembly and makes that one a editable part. Okay. So the thing comes up in your graphics window, and what it'll do is it'll gray out the other parts that are in the model tree on the left hand side. Something else, and I'll talk about this in a couple minutes when we start doing an assembly together, but you have to ground the first thing that gets put into your assembly. Now that is one of the options that you can set up, to ground the first instance of the first item that gets put in, and I'll show you why that's important in a few minutes. Degrees of freedom, that is where you take your constraints and you start adding them to the components, and what that does is that keeps things from moving unexpectedly, I guess is the best way to put it. The minimum amount of numbers of degrees of freedom are going to be when you have 3 degrees of freedom for transitional things. So if I have a lever that goes up and down like this, there's going to be 3 degrees of freedom for this lever, in and out, up and down, and left and right. So we'll look at how to work with degrees of freedom. They're kind of useful for us. Constraints are what we use to hold things in place. You're going to see this little dialog box down here on the right hand side, and we're going to be messing around with that in a few minutes, so you'll hopefully get the way that starts to work. There are multiple different ways to constrain things. First is a mate constraint. That's this one that looks sort of like a flagpole with a white box at the bottom of it. And you'll see solutions set on here also. You'll see a little arrow pointing to the left here, and you'll see another arrow pointing to the right. That means that those two surfaces are going to mate up, and like this. And then we have what's called a flush mate. That's where the two surfaces are in a line this way with each other. So different kinds of constraints. We also have angular constraints that we can put onto things. You can see that this part on the top is rotated probably 30 degrees or so from the part that's on the bottom. And then again, the solutions here, you can choose these and find the solution that works for your assembly. We can also do tangency constraints. Not something I use a whole lot, but it is there if I need it. Assembly of pins into holes. This is like a socket head bolt, and what you do is you mate this circle on where the shaft of the bolt comes into the head. You mate that to this edge of the hole right here, and again, here are the solution sets for those. That puts things together. We're going to do some of those kinds of things later. This is a symmetry constraint. Frankly, I have never used this one. I've not had to use it. You might someday. Just be aware it's there. This is a motion constraint, and we use this with gears and pulleys and rack and pinions. You can drive one component, in other words, make one component move, and then the others move accordingly to the constraints that are placed on them. Rotational constraints, they are going to rotate in relation to something else, another component that's rotating, and you can specify a ratio for the rotation between two components. We also have motion constraints, and these are transitional ones. We would use these in things that are like cams, off-centric cams that run kind of like in a pear shape or an oval shape or a shape of the letter P, something of that nature. That's to keep the follower against the surface of the cam. So this circle right here, that's the follower. Then we have the surface of the cam here, and that puts those two things together so that, maybe this is a better way to do it, so that this thing will ride up and down up here. It's kind of fun to mess around with a little bit. Constraint sets, I don't use those, really don't know what it is. And then selecting our geometry, and this is an automatic constraint right here, and you push the Alt key and then you drag your item near to the location you want it to snap onto, and it should go there. That works for me about 80% of the time. 20% of the time it just flusters me. But anyways, so let's keep going here, go through this, and that gets us to our first exercise, which is 6-1. So I'm going to conclude this video right here, and then we will do exercise 6-1 in the next video.